Mr. Kumar Ashish asked a very good question in regards to problem 2.1, which I'll go over in a second down here, but he asked, is there a general expression for the number of polygons for these types of problems, and specifically in terms of number of n sides? So let me first review that problem. So again, this is problem 2.1 in the textbook, where we have a 13 solid-sided polygon where all the charges with charge Q are situated equidistant from each other. And we have put a test charge right dab in the middle, and we just want to know the total force on the test charge Q. So we'll go ahead and say, put the total force on the charge Q, test charge Q right here. And we know for a single charge, right? We'll just go ahead and take this charge relationship and just ignore all these other ones real quick. So for just one little charge right here, we know that Coulomb says that the force on the test charge is equal to 1 over 4 pi epsilon naught Q times big Q over r squared, and it points in the direction from that charge causing the force away from the test charge, right? So that we'll just go ahead and call that r hat. And if we're dealing with more than one of these charges, even though they all have the same charge, let's say if we expand it to 2, right, then we're going to have to change our perspective right now, right? So if we do a more general term, right, we're going to have to say that we would have to add those two together. So we'll have to add indices. We'll have to add numbers to them. So we'll just call this number 1, number 2. And so if we have the force from both of those two, it'll be 1 over 4 pi epsilon naught. We just have to add them together. So it'd be Q1 times our test charge, R1 squared, because we'll have to call this R1, and then this one would be R2. Oops. R2. And then we have, let's see, R1 hat, where R1 hat is in this direction, and then R hat 2 would be in this direction, 1 and 2. So that's R hat 1, and then we simply add 4 pi epsilon naught Q2 Q over R hat, or R squared, R hat 2. Right? And then we can go ahead and pick out some of the things that are common to all these, like this 1 over 4 pi epsilon naught and Q. And so we can go ahead and pull these out. So 1 over 4 pi epsilon naught, and then Q right here times the Q1 over R1 squared plus, putting in the R1 hat direction, and then Q2 over R2 squared, putting the R2 hat direction, right? And if we want to go really general on this thing, right, then we just can go ahead and just add a summation. So the total, the general, going back to Mr. Ashish's question, is that the total, let's give it a little bit more room. The total force would be equal to summation, and we can, since these don't have indices, we can move this outside of the summation. It's equal to the summation of, if we start with some index equals to 1 all the way to n, if we have a general number of n questions, or n charges, is equal to qi over ri squared over ri hat, right there, to go in line with that. So that would be the general term. If we had a number of n sides, because we have 13 if we have 13 charges, we have 13 sides, right? So that kind of directly answers this question. But the total force, and this is where kind of the physics comes involved, is you know that there's always going to be an equal opposite push whenever you have an equidistant polygon. All the charges are equidistant right here, right? So no matter what, no matter how many sides, as long as they're all equidistant right here and they all have the same charge signs and magnitudes, the total force is always going to be equal to 0. And so we can also expand this out and kind of make a toy model as an example. So if we have a test charge Q here, and we put 2 charges that are equal and opposite, right, or equal distance. So we have 4 charges, we have 4 sides, right? And so there's always going to be a charge from this one onto the test charge pointing in this direction, and a charge from this one pointing in this one in this direction, and so goes forth for those ones. The total charge here is always going to be equal to 0. But if you wanted to use it in general terms, this is the expression you'd use.